Hello students, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in today's session, we are going to start the new chapter, that is motion in a plane, which comes under again the kinematics part. So in the kinematics, first we dealt with the motion in a straight line. So where in 5 lectures I have completed the whole motion in a straight line, and then next we are going to start the next part of the kinematics, that is motion in a plane. So first, to understand the motion in a plane, so we should have the complete knowledge of vectors, so which is the basics of physics. So these vectors will be useful in every other chapter of first year as well as second year, like +1, +2 I am talking about. So in every chapter, so the vectors concept will come for sure. Okay, so that's why in the first session of motion in a plane, so we are going to just see the basics of vector and how do we add and subtract the vector, that is vector addition and subtraction. So this is very important for every other chapter. Okay, it's like a prerequisite of physics. So like how basic maths is a prerequisite for physics, so in the same way, so the vectors also is a prerequisite to study every other chapter of physics. Okay, chalo. So and in this chapter also we are going to see, so especially the relative velocity, so where the concept of vectors is very useful. Okay, chalo. So first today's lecture I am going to keep it short. So just we'll understand what are the vectors and what are the types of vectors, how do we find the angle between the vectors, and how do we add two vectors, and what's the addition of two vectors formula, and by how many ways we can add the vectors, what are the methods, and then how do we subtract the two vectors, and we are going to solve some numericals as well. So as usual, for the next 1 hour or 1.5 hours, just be with me, avoid all the disturbances around you guys, and at the end it's a very important to write the summary or the short notes on your own. So just spend 10 more minutes after the lecture and then prepare your own short notes and revise it daily. So and whatever the chapters till now we have covered, so like whether it's basic maths or units and measurements or motion in a straight line, so 3 topics I covered. So what you do is write all these summary at one place if you haven't prepared till now. So prepare the summary and revise it daily early in the morning. So just at least for half an hour you should go for the revision. So do it for all the subjects. So it will be very beneficial for you, and you will understand the importance of it when you are going to attempt the competitive exam like cumulative exam. So when a short test is there, you will not understand the importance of short notes, because short test just, so whatever the chapters that are covered in that week, so that will come, however you will remember because you studied in that week, so you can easily go and attempt the test. But when you are writing the test of 10 chapters, so in this week you studied the 9th and 10th chapters, remaining 8 chapters you have studied previously. So recalling those 8 chapters, formulae, shortcuts, tricks, so theory, all these things in a short time is impossible without the short notes. Okay, so that's the importance of short notes. Okay, so you are in the beginning stage for your preparation, whether it's JEE or NEET or for your boards, whatever, because you have just started the academic year. It's the right time to plan the things. Okay, especially the short notes, and don't creating the backlogs. This is very important. So I will not take your much time. So let's get into the topic of today's. Chalo. So first, what are vectors? So in class 9th you have studied, so the vector is nothing but which has the magnitude plus direction. The vector is a physical quantity which has magnitude as well as direction. Magnitude plus direction. Now, so what is magnitude and what is direction? So magnitude is a value in the units and measurements we have seen. So direction, so it tells in which direction this is. Okay, for example, I am going 5 km per hour. I am walking at a rate of 5 km per hour, let's say. Okay, so 5 km per hour, am I going in the east direction or west direction or south direction or the north direction, right, left, up, down? So I'm not saying anything. So 5 km per hour is just the magnitude. So if I say I am going towards east, so then it's a direction. So any physical quantity, so which has magnitude as well as direction, so then it's said to be a vector, right? So the symbol of vector, let's suppose A is a physical quantity which is a vector, so then we represent that as vector A like this. So arrow on the top of it, head of it. So then, so it will have the magnitude, so where this represents the magnitude. So the mod of vector A, this represents the magnitude, and the unit vector denotes the direction. So this gives the magnitude, this gives the magnitude, and then this gives the direction. Again, in the tomorrow's lecture, we will study, so what is a unit vector in different directions. If it is 1D, just, so it's a east, I say only one, that's why I just write unit vector. But in the 1D, 2D, 3D, so how do we write the unit vector? And for a vector which is in 2D and 3D, how do we take the magnitude? So those all things you will understand while the classes progress. Okay, so just as of now, you just remember, so any vector can have the magnitude, this is the magnitude, and this is the direction. Okay, chalo. So and in the vector, whatever the symbol that you are representing, in this symbol, so we call this as, so this is head, and then this is tail, head and tail. So a vector is represented like this. For example, a person is moving with a speed of 10 km per hour. So 10 km per hour is the magnitude. Let's say east direction is moving. So this is a 10 km per hour is a magnitude, whereas east is a direction. So this complete thing is a vector. Okay. So but if I just say 10 km per hour, it's not a vector. It's just a scalar quantity. It's a speed. 10 km per hour is a speed. So this is a velocity. Velocity is a vector quantity. Velocity is a vector quantity, right? So you know the different vector quantities. So just for example, so we can write, so the displacement is a vector quantity. Yes or no? So the displacement will have the direction. So as well as velocity is a vector quantity, right? So force is a vector quantity. So like that, so there are many vector quantities, so which you can write, etc. as will understand. So like what are vectors, what are scalar, which term is a vector, which term is a scalar, as classes progress and different chapters are covered. Okay, so these basics are clear related to the vectors. Now, so then what are the different types of vectors? So the next thing is, so what are the different types of vectors? Chalo. So let's go for, so is there a slide for that? Yes, so just don't need to add. So just go for the types of vectors. So there are different types of vectors. So the first one, let's say the equal vector. So just I'm not going to write the complete theory related to it. So you just write it in your own words. I'll explain through the diagrams. Okay, equal vectors means, so the vectors which have same magnitude and same direction. So the two vectors which have same magnitude and same direction, they should have the same magnitude as well as same direction. So they are said to be the equal vectors. So that means I can say here, let's say this is a vector A. Let's say this is vector A, and let's say this is vector B. So if you observe, these two have the same magnitude. These two vectors have the same magnitude, right? So their length represents the magnitude and the arrow represents the direction. So you can write that part also here. So the length of arrow, the length of this one, the length represents the magnitude, whereas the arrow represents the direction. This arrow represents the direction, in which direction it is moving. Okay. So now here I can say that the vector A is equals to vector B. These two have the same magnitude and same direction. So these are the equal vectors. And then, so we have parallel vectors and unparalleled, non-parallel vectors. So parallel vectors, so then non-parallel vectors. So parallel vectors are nothing but, so they should have the same direction, but their magnitude may be or may not be equal. So their magnitude need not to be equal, but their direction should be same. So that's why this is vector A, let's suppose. So this is vector B. So they both should be in the same direction. So either towards the right or towards the left or at an inclined angle. So their direction must be same. So and exactly opposite is the non-parallel vectors. So with non-parallel vectors, we can write one is right side, one is left side, parallel and non-parallel vectors. Clear? So you can write that also. So then next I'll go for the negative vector. This is important. The negative of a vector. So the negative of a vector means, so same magnitude, opposite direction. Same magnitude, the vector which is having the same magnitude and then opposite direction. Same magnitude and opposite direction. So such vectors are said to be, so the negative of a vector. Okay. So here the parallel thing you can write like this. The symbol A is parallel to B. Okay. Chal. Next here. See here. So for example, if I write, so the vector A like this. This is a vector A. So then write the negative of vector A. So then I can write simply same magnitude but opposite direction. Same magnitude, opposite direction. So let's consider this is vector B. So I can say the relation between them as, so a vector A is equals to minus vector B, or minus B is equals to, or B is equals to minus A vector. So in either way you can write that. Clear? So this is the negative of a vector. So here parallel vectors and unparallel, non-parallel vectors, and then equal vectors, and then so the next one, so the orthogonal vectors. The orthogonal vectors. So orthogonal vectors means, so the vectors which are perpendicular to each other. So the vectors which are perpendicular to each other. For example, so there is a vector which is in the x direction, and then so there is some vector which is in the y direction. Let's consider the A vector is in the x direction, B vector is in the y direction. So then I can say that A is perpendicular to B here. So A is perpendicular to B. So we can say A, B vectors are orthogonal. A, B vectors are orthogonal. Or, so next, let's suppose if I take in the z direction, let's suppose C vector is there, for example. So then vector A plus vector A and vector B, all three are mutually perpendicular, and vector C, all three are mutually perpendicular. So and in this case I can say A, B, C are again orthogonal, right? X, Y, Z means each will be perpendicular to one another. These are the orthogonal vectors. Hope you guys are understanding the basics of vectors, right? Chal, next. So the next thing is the collinear vectors. Collinear vectors. So what does it mean by collinear? Collinear means, so which originate at the same point or terminate at the same point. So for example, if I say, so this is a vector, the collinear vector which lie in the same line, they are said to be collinear. So they which lie in the same plane. Let's suppose this is a vector A and then this is a vector B. So here I can say vector A and vector B are along the same straight line. So they are said to be collinear. They are said to be collinear. Clear? And then, so the next type of vectors, so that is, so coplanar. Coplanar vectors. Coplanar vectors. So what does it mean by coplanar vectors? So which lie in the same plane. Which lie in the same plane. The vectors which lie in the same plane, they are said to be coplanar vectors. Let's suppose, so this is the x-axis and y-axis. So this is the xy plane, right? So in the xy plane, there are two vectors. Let's consider this is a vector A which is in the xy plane, and this is a vector B which is in the xy plane again. So then we can say, as those two vectors are in the same plane, we can say A and B are coplanar, which are in the same plane, Clear? Understanding? So these are the different types of vectors. So negative vector, parallel and unparallel vectors, so equal vectors, orthogonal vectors, and then so collinear vectors, coplanar vectors, and we have one more vector, so that's called unit vector. So we'll understand the importance of unit vectors in the next class. So just have the introduction now. So unit vector, so the only purpose of unit vector is to give the direction. So its purpose is to give direction. The purpose of a unit vector is it gives a direction. That's it. Okay. So what is unit vector? As I told you earlier, for example, there is a vector x. So this x vector will have the magnitude as well as it will have the direction. So this direction, this is nothing but the unit vector of x. So from here, what you can write the formula for unit vector? X cap is equals to vector x by the magnitude of x. Or let's suppose some a is a vector. Okay. So then this vector can be written as, so magnitude of vector a and vector a direction. So then from there, unit vector of a is vector a by, so the magnitude of vector a. Clear? Understanding this part? So this is about the unit vector. Everyone clear with this? So just understand the things. So equal vectors, parallel and unparallel. So negative of a vector, orthogonal vectors, and then so collinear vectors, coplanar vectors, unit vectors, and in the collinear, so like in the co-initial and co-terminal vectors also be there. So let's suppose I'll write it here. See, if a vectors are originating at the same point. So for example, this is a vector A, and then this is a vector B. So and then this is a vector C. So all three vectors are originating at the same point. Okay, they are originating at the same point. So they are said to be co-initial vectors. Okay, these are said to be co-initial vectors. Okay, so that's not that much important. And co-terminal also will be there. So which will end at the same point. So which end at the same point. Clear? Understood till here? Chalo. So this is just the basics of vectors and what are the types of vectors. How do we represent the vectors? So now the thing is, how do we find the angle between two vectors? So the next thing, that is angle between two vectors. How do we find the angle between any two vectors? So the rule to find the angle between two vectors is, so those two vectors must be connected tail to tail. The only condition is that the vectors must be connected tail to tail. Then the smallest angle measuring between them is said to be the angle between those two vectors. I'll tell by an example. See here. So for example, let's suppose if I say there is a vector A and then there is a vector B. So this is vector A, this is vector B. So let's say the angle between these two vectors is 60 degrees here. I am saying this angle is 60 degrees. Now if you observe, the vector A tail is connected with vector B tail. So those two vectors are connected tail to tail. So then the angle between those two, so there are two angles, right? So what are those two angles? One angle is this. So and the other angle is this. So this angle is 300. So now which angle I should consider as the angle between those two vectors? So the smallest one, the smallest angle, that's what I wrote here. See, so the angle between two vectors is the smaller of the two angles between the vectors when they are joined tail to tail. When they are joined tail to tail. See here. So here two vectors are joined tail to tail, and between these two tails, here one angle is 60, other angle is 300. So then which angle we should consider? The smaller one. So obviously the angle between these two vectors is 60 degrees is the correct one. Okay. So then next. So if two, for example, if I take one more question. So this is a vector A and then consider this is a vector B. So let's say if I take this angle as some 150 degrees. Let's say this angle as some 150 degrees. So then find the angle between A and B if I say. Find the angle between A and B. So don't directly say that the angle between A and B is 150. No. Why? Because see here, the vector A head is connected to the vector B tail. So to measure the angle, what's the condition? So the two vectors must be connected tail to tail. They must be connected tail to tail. So your tail to tail is not there. So in these cases, what you can do is the parallel shifting of vectors is allowed. The parallel shifting of vectors is allowed. What does it mean by parallel shifting of vectors is allowed? So a vector can be shifted parallelly without changing its magnitude and direction. For example, if I say this is a vector A, so I can shift this vector so in the same direction, in the same magnitude, with the same magnitude, so here, or else I can shift this from this vector to here also without changing its magnitude and direction. So I can shift this without changing the magnitude and direction. Okay, so this one. Understanding? So you'll understand through the example. See here. So consider this example here. So now what I am doing is, so let's shift this vector A. So this vector A is here. So now I am shifting it to this side. So this vector A, without changing its magnitude, I am shifting it here. So same magnitude and in the same direction. Right? So now these two vectors are connected tail to tail. See here, vector A tail and vector B tail are connected. Now the angle between them will be this one, those two vectors. Obviously, if it is 160, this is 150, so this is going to be 30 degrees. So therefore, the angle between those two vectors is going to be 30 degrees, not 150, because the angle should be measured when two vectors are joined tail to tail. Got my point? Clear? Chalo. So or else you can take one more example. See here. So let's consider this is the example 1. So this is example 2, and then let's say this is example 3. So the same thing. So what we can do here? So vector A tail, vector B head connected. So the angle is not going to be 120 degrees, obviously. So what I am doing is, so let's parallel shift the vector B. Let's parallel shift the vector B to this side. Okay. So then if it is 120, so this must be 60 degrees because this is a straight line, right? So the straight line makes 180 degrees, basic maths. So if it is 60 degrees, so then the angle between them will be 60. Smallest angle we should take. The outside one, 300 will be there, right? So you should not take the larger one. So you should take the smaller angle. Understood? Clear? So then, so for example, if I take, so one more question. So let's suppose this is a vector A. Consider this is a vector A, and consider, let's suppose, so this is vector B. Okay, so let's say this angle is some 160 degrees. So then how do you find the angle between vector A and B? So it's not going to be 160, obviously, because the vector A head and vector B tail are connected. Now what we should do? So either parallel shift the B vector to this side or parallel shift the A vector to this side. So I am parallel shifting the A vector, so to this side. So this will be the easier procedure. So as it is a straight line, this is 160, this must be 20. So therefore the angle between A and B is going to be 20 now, because the vectors A tail, vectors B tail are connected here. So this angle is the 20 degrees, is the correct one. Clear? So finding the angle between the two vectors is understood, everyone, this concept? Chalo, next. So now the important thing next, so the vector addition. So here, so the vector addition actually, so to discuss this vector addition, so we can do it by two methods. One is a geometrical method and the other one is a analytical method. Okay, so actually we are interested in the parallelogram law, so I'll discuss the parallelogram law. But actual for vector addition, if you need, I'll write the flow chart here. See here. So the vector addition, any two vectors can be added by two different methods. The vector addition. So one is geometrical method and the other one is a analytical method. Analytical method. Okay, so these are the two methods. So in the geometrical method, again, two methods are there. So under the geometrical, not two, three. So again, under the geometrical method, so one is a triangle law, and the another one is a parallelogram law, and the next one is a polygon law. Polygon law. So here in analytical method, two methods. So one is triangle law, and the other one is a parallelogram law. So what's the difference between these two, sir? Analytical and graphical. So here we just represent the solution, the resultant vector, by diagrammatic form. Okay, so not by the solution, like how much is the magnitude, and this thing, it cannot be represented. There is no formula. Just this is a diagrammatical method. That's why it's a geometrical method. So triangle law, parallelogram law, polygon law. As the class progress, you'll understand all these things. Don't worry. Okay, just have the outlook. So then analytical method. So we have triangle law and then parallelogram law. So where here formula will be there. Here there will be formula to find the magnitude of the resultant vector. Here we just have the direction of the resultant vector. That's it. So diagrammatic form. So we can't say how much magnitude is the resultant is having. So you can't say by this one. So you can say it by analytical method. Okay, chalo. Both the procedures are important. I'll combine these two and tell. So okay, chalo. So first the parallelogram law. So what is parallelogram law? So if I say diagrammatically, so our geometrical method, so when two vectors are connected tail to tail, for example, so two vectors, let's say this is a vector A, let's say this is vector B, vector A and then vector B. So now, so the parallelogram law says that, so first form the parallelogram. So how do you form the parallelogram now? So the simple logic is, the parallel shifting of the vectors is allowed. We know that the parallel shifting of the vectors is allowed, right? So I can parallel shift the vector A to this side. I can parallel shift the vector A. So from here to here, vector A is parallel shifted. And then I can parallel shift the vector B as well. Vector B is here. So I'm parallel shifting the vector B to this side. Now, the resultant will be given by, so the diagonal of the parallelogram. So the resultant will be given by, so the diagonal of the parallelogram. Okay, understood guys? So now this is a resultant, where this resultant will be equals to, so the vector A plus the vector B. The vector A plus the vector B. Clear this part? Everyone? Sure. So this is the geometrical method. In the geometrical method, parallelogram law is there, na? So the geometrical method talks till here. That's it. So if two vectors are given, so then form a parallelogram with those two vectors by, so parallel shifting those two vectors, and the diagonal of the parallelogram will give the resultant. So what is the magnitude of this resultant? So that's not given by the geometrical method. Now we should go for the analytical method. Till here it's geometrical. In the under the geometrical method, parallelogram law. This is. So now I am going for the this one, analytical method, parallelogram law, right? Analytical method. Okay, chalo. So see here. Now, so what I am doing is, let's consider the angle between these two vectors is theta. So between A and B, the angle between those two vectors is theta. So now, see, let's do one thing. So I am drawing a line here, the perpendicular line from here to here, and then I am connecting this. Okay, so let's name this one. So I am naming this point as P, this point as Q, this point as R. Okay, so then let's consider this point as S, P, Q, R, S. Let it be P, Q, R, S. Okay, so now So from here to here, it's going to be the magnitude of vector A. This is the magnitude of vector A. Sometimes the magnitude of vector A simply can be written as A. If I write simply A, that means it's a magnitude of A. Okay. So now, so if this angle is theta, so this angle, this total angle is going to be theta. If this angle is theta, so then this angle is also going to be theta. So then we know that this is the vector B. This is the vector B. So now let's take this PQR triangle aside. I am taking the PQR triangle aside. Just understand the basic maths part here. So the PQR triangle, I am taking it aside. So this is the angle theta. So now from here, so shall I write the sine theta is equals to opposite by hypotenuse. Opposite is PQ, hypotenuse is PR, right? So from here I can write PQ is equals to PR into sine theta. PQ is equals to PR into sine theta. So from here PQ is equals to, what is PR? So the PR is nothing but the B. So the magnitude of B, right? So I can write PQ is equals to, in place of PR, the magnitude of B sine theta. So just let it be aside. In the similar way, from here, let me write what is cos theta. Cos is adjacent by hypotenuse. Adjacent is QR, by hypotenuse is PR. QR by PR, right? So then, so from there, QR is equals to, shall I write PR cos theta? PR cos theta. So QR is equals to, PR is nothing but B, the magnitude of B. So B cos theta. B cos theta. So this is a QR. So now I can write here, see here carefully, this PQ is nothing but B sin theta. And then this AQ, this QR, this QR is nothing but from here to here, it is going to be B cos theta. Okay now. So now, so this whole thing, shall I consider it as A plus B cos theta? This whole thing is A plus B cos theta. From here to here it is magnitude of A. From here to here it is B cos theta. Now again from this, so I am taking the triangle PQS. So understand, see the triangle PQS. So again I am drawing it aside. Okay. So consider the triangle PQS. So this is the P. Just see the diagram properly. P, and this is Q. And then this point is S. From here to here, this whole thing I am taking. So this is a perpendicular. This is 90 degrees. So this angle is 90 degrees. So now from here, shall I write? So this S to Q, from here to here, the total distance is A plus B cos theta. A plus B cos theta, right? So and then what is this SP? So this SP is nothing but the resultant R. The SP is nothing but the resultant R, magnitude of the resultant R, let's say. So then this PQ is nothing but B sin theta. B sin theta. So here triangle PQS. So can we apply the Pythagoras theorem, as it is a right angle triangle? So we can apply the Pythagoras theorem there simply. So that from Pythagoras theorem, so we can say that, let's write the line here. So let's write the line here. So chalo. So now see here. So we can write the PS whole square is equals to, so PQ whole square plus QS whole square. Yes or no? So what is PS whole square? R square is equals to PQ. In place of PQ, I can write B sin theta whole square plus, so QS, what is QS? A plus B cos theta whole square. A plus B cos theta whole square. Now let's expand these. So I can write R square is equals to, this is going to be B square sin square theta plus, so this is A plus B whole square. Consider this whole thing as B. So then A square plus B square. B square means B square cos square theta. So plus 2AB. B, in place of B, we can write B cos theta. In place of B, we can write B cos theta. So from here, I can write R square is equals to, so let's write A square at one place. So here B square is there, here B square is there. Let's take B square common. So in place here sin square theta, here cos square theta, right? So plus 2AB cos theta. plus 2ab cos theta, right? So then here I can write r square is equals to, so a square, so this is the trigonometric identity, sin square theta plus cos square theta, which is equals to 1. So that's why b square into 1 b square plus 2ab cos theta plus 2ab cos theta. So this is the magnitude of the resultant. So when two vectors a and b are joined tail to tail, so let's the angle between them is theta. So then by parallelogram law, so we can say that the resultant is the diagonal of that parallelogram. So which is, this is a parallelogram diagonal. So the resultant is equals to r square is equals to a square plus b square plus 2ab cos theta plus 2ab cos theta. Or if you need what is the magnitude, just the magnitude, so then send the square to that side. So which is going to be a square plus b square plus 2ab cos theta. This is the analytical method. So by analytical method, you can say how much is the magnitude of the resultant. Okay. So but by geometrical method, you can just represent it in the diagram. This till here it's geometrical method only. So here this is a analytical method by which you got the magnitude of the resultant. So now my question is, so okay sir, the resultant magnitude we got it. Now what's the direction of this resultant analytically? So what's the direction of this resultant? So let's consider this resultant is making some angle alpha with the a vector. This resultant is making angle a alpha with the vector a. Okay. So then what I am doing is, see here. So let's consider this angle as alpha. So then shall I say the tan alpha in the same triangle? So the tan alpha, this angle, right? So the angle between vector a, this is a vector a, so total, and then this is a resultant. So the angle between, yes or no? So this is a alpha, this is resultant. Here this side vector a is there, right? So this is the alpha. So from same triangle PQS, shall I say that the tan alpha is equals to opposite by adjacent? What is opposite? B sin theta by a plus b cos theta. So b sin theta is the opposite, and then adjacent is a plus b cos theta. A plus b cos theta. That's it. Clear? So this, that means, so how you are saying the directions are this one? We can say that the vector, the resultant is making some angle alpha. So what is that alpha? So that alpha is equals to tan inverse of b sin theta by a plus b cos theta. So this much angle it's making with the a vector. So no sir, I need the angle between resultant and b. So that also you can find, let it be beta. So you can simply say that alpha plus beta is equals to theta. The alpha plus beta is equals to theta. So then from there beta is equals to, we can write theta minus alpha. Beta is equals to, we can write theta minus alpha. That's it. Okay, clear? You find alpha value and then subtract alpha from the theta value so that you will get the beta. So what is beta? The angle between resultant and vector b. So what is alpha? The angle between vector a and the resultant. Okay. So how do you find the magnitude of two vectors having the angle between them? So addition I am talking about, square root of a square plus b square plus 2ab cos theta. So simply I can write, for example, if there are two vectors p and q, so just write the formula along with me just to remember. So let's suppose p is a vector and q is a vector. So let the angle between them is theta. Let the angle between them is theta. So then I am saying find so p plus q, find the vector p plus vector q. Okay. So now simply we can say that, just if you want you can draw the rough diagram here. So the vector p is here, so the vector q is here. So let the angle between them is theta. Okay. So then what we do? So we parallel shift the vector q, we parallel shift the vector p. So then the resultant will be given by the diagonal of the parallelogram. This is the resultant. So how do you find the resultant? We already know the formula. So the resultant magnitude, so the magnitude of the resultant is going to be square root of, so what are the two vectors here? P and Q. So P square plus Q square plus 2PQ cos theta. That's it. This is the resultant. Okay. So the resultant is what? Which is vector P plus vector Q. Okay. And then if you want to find what is the direction, so then tan alpha is equals to, so what is this going to be? So this vector is Q. So this is Q sin theta by P plus Q cos theta. Yes or no? P plus Q cos theta. That's it. So just I converted this from A to B to AB to PQ. That's it. Nothing more than that. Understood, guys? Clear this concept? Sure. So just have a look once. The vector addition important. Now let's see some questions based on this. So what's the question says? So the magnitude of vectors A, B, C are given. So the given, what's the first thing given? So the magnitude of vector A is 3. So the magnitude of vector B, which is 4. So the magnitude of vector C, it's given 5 respectively. So if A plus B is equals to C, so the A plus B is equals to C. So then what they are asking? So find the angle between A and B. So we have to find the angle between A and B. So you know the C magnitude. C is nothing but the resultant, I can say here. So we can say that, so the magnitude of the resultant square is equals to, or the magnitude of the resultant is equals to simply A square plus B square plus 2AB cos theta as per the vectors formula, vector addition formula. C is the addition of these two things, right? So in the previous case, if the resultant R is equals to A plus B, so then what's the resultant formula? Magnitude of resultant is going to be square root of A square plus B square plus 2AB cos theta. Similarly, the magnitude of C is going to be A square plus B square plus 2AB cos theta. That's it. So from here, we already know what is the magnitude of C. So the magnitude of C is 5. And then, so A means magnitude of A square, which is 3 square. So magnitude of B square, 4 square plus 2 into magnitude of A. So 3, magnitude of B, 4 into, so the cos theta, right? So from here, 5 is equals to square root of 9 plus 16 plus, so this is 6 into 4. So 24 cos theta, right? So from here, 5 is equals to, let's squaring on both the sides. So this is going to be 25, 5 square, and then this is going to be root cancels. So 25 plus 24 cos theta. So from here, so the 25 cancel. So the 24 cos theta is equals to 0. So cos theta is equals to 0. So for which angle the theta is going to be 0? So cos 90 degrees. Cos 90 is 0, right? So therefore, so the angle must be 90 means pi by 2. So, right? Cos pi by 2. In the radians it's given. So, and you know the conversions from degrees to radians, radians to degrees. Right? Simple question. Next. So what are the special cases? So the special cases, let's see. If there are two vectors, the resultant, the magnitude of the resultant we got. So we know that P A square plus B square plus 2AB cos theta. So this is a magnitude, right? So now, so the case 1, let's suppose if the angle between those two vectors is 0. So the case 1, if the angle between those two vectors is 0. So if the angle between those two vectors is 0, so those two vectors are said to be the parallel vectors. Those two vectors are said to be parallel vectors. So if the theta is 0, you substitute theta 0. So then what happens? The magnitude of the resultant will be equals to square root of A square plus B square plus 2AB. So cos 0 is going to be 1. In place of theta, if you substitute 0, so the cos 0 value is going to be 1. So then, which is going to be square root of A square plus B square plus 2AB. So this formula, see here, this is nothing but A plus B whole square, right? So from here square root cancel. So that means A plus B. So the magnitude of the resultant is going to be simply, so the magnitude of A plus the magnitude of B. You can write like this. So the magnitude of A plus the magnitude of B. So this is also called the R max. So the resultant will be maximum when two vectors are parallel to each other, or the angle between them is 0 degrees. So the resultant maximum will be equals to simply the magnitude of those two vectors. Okay, this is the first case. So now if I consider the angle between those two vectors as 180 degrees, so they are said to be anti-parallel vectors. Parallel vectors and anti-parallel. Anti-parallel means reverse. So which is theta is equals to 180 degrees. So which is nothing but anti-parallel vectors. Anti-parallel vectors, right? So from here I can write, so the resultant formula, which is square root of a square plus b square plus 2ab cos theta, right? So from here, what is cos 180? Already we have seen it in the basic maths. Cos 180 is minus 1, right? So therefore the square root of a square plus b square, so plus 2ab, so this is minus 1. Cos 180 is minus 1. So then I can write this as square root of a square plus b square. So this plus into minus minus 2ab. So this is a formula of a minus b whole square, simply a minus b whole square. So square root cancel, it's simply going to be a minus b. So the magnitude of vector r is equals to magnitude of vector a minus magnitude of vector b. So this is said to be r minimum. The resultant will be minimum. So when those two vectors are anti-parallel to each other. So those two vectors are anti-parallel to each other. Clear this part, everyone? Chalo. Next. So the third case, let's take the case 3, where the angle between the two vectors is 90 degrees. So what are those two vectors are said to be orthogonal. Okay, so 90 degrees means they are orthogonal. So then see here, so let's say resultant formula magnitude is equals to a square plus b square plus 2ab cos theta, right? So why I am writing these many times means you should remember. Okay, you should also write along with me. So a square plus b square. So we know that cos 0 is 0. Cos 90 is 0. So cos 90 is 0. So 0 into something 0. So this whole thing will become 0. So square root of simply a square plus b square. So the resultant, the magnitude of the resultant will be equals to square root of a square plus b square. So that means when two vectors are perpendicular like this, so this is a vector a and this is a vector b. So this resultant will be, so which is equals to square root of simply a square plus b square. This is a square plus b square, the magnitude of square. So clear? Chalo. Next. So if you want to find the angle, let this be angle. So then the b sin theta by a plus b cos theta, you can find the angle as well. So now the conclusion is, so the resultant will be maximum when two vectors are parallel. So that means what is that resultant maximum? So just adding the magnitude of those two vectors. So if the resultant is minimum, so when the resultant will be minimum, when those two vectors are anti-parallel, right? So that is a minus b. So if you add any two vectors, so the resultant will always lie between maxima and minima. So what is that maxima and minima? So the resultant will lie between, so it r max and then the minimum is r minimum. So we can say that, so the resultant, so which is, so the a plus b, this is a plus b and the minimum is a minus b. So resultant is a, this is a plus b and this is going to be a minus b part. Clear everyone? Understood? So let's move further. So these are the three different special cases. which you should remember. Okay. Chalo, next. So let's take one question. What's the question says here? So first try to understand the given question. So the maximum and minimum magnitude of resultant of two vectors are given 17 and 7 units. So understand this statement properly. So what is maximum magnitude of the resultant? So maximum means, shall I say R maximum is given, so which is 17. So R maximum means, so let's consider those two vectors are A and B. So simply I can say that A plus B is given as 17. Yes or no? And minimum is 7 units. So the resultant minimum is going to be 7. So the resultant minimum is A minus B. Just now we have seen, which is 7. So now if these two vectors are right angles to each other, so the magnitude of their resultant, let's find the magnitude of each vector first. So we have got what is A plus B and what is A minus B. Simply add these two, so that 2A is equals to 24 and then A is equals to 12. So if A is 12, so the B must be equals to 5. If A is 12, B must be equals to 5, right? So now next, so what they are saying, these are the magnitudes of two individual vectors. So if these two vectors are right angles to each other, so that means angle between them is 90. So this is a vector A, which is 12, and this is a vector B, which is 5. Okay, so then the angle between them is 90 degrees perpendicular. So then what is the magnitude of the resultant? So this resultant magnitude we should find. So just now we have seen, whenever two vectors are perpendicular, so the resultant will be simply square root of A square plus B square. So which is square root of 12 square plus 5 square. So square 12 is 144 plus 25. So square root of 169, which is nothing but 13. That's it. So or else you can directly say that it's a Pythagorean triplet, right? So 12, 5, 13 is a Pythagorean triplet. So obviously the resultant is going to be 13. Option D. Simple question. Clear? Everyone? Chalo. So now, so you should remember some standard results, guys. So those standard results for two equal vectors. So again I am saying for two equal vectors. So two equal vectors means, so they should have the same magnitude. Those two vectors should have the same magnitude and having some angle between them. So two vectors having the same magnitude, some angle between them. So for example, if I say, so there is a vector F, so and then, so the vector F. So if these two are, this is F and this is F. So these are the two vectors which are perpendicular to each other. So then how do you find the resultant between them? So the resultant is going to be simply, so the square root of F square plus F square, we know that this one. So which is nothing but 2F square. So F square, if you take it out, F root 2. So blindly you can consider, whenever two vectors are having magnitude same and the angle between them is 90, so then that resultant is going to be, so that magnitude into root 2. So F root 2. Okay, so that's the first standard result you should remember. And when two vectors are having same magnitude, let's suppose F and F, and then so the angle between them is 60 degrees. Consider the angle between them is 60 degrees. So then the resultant comes out to be F root 3. So if you want, you can just substitute theta is equals to 60 degrees. R is equals to square root of A square plus B square plus 2AB cos theta. So in that, A is equals to F, B is equals to F, theta is equals to 60, you substitute. Do it as a homework. So the resultant comes out to be F root 3. Okay, so do it as a homework. Right? Chalo. So that's one more standard result. And then, so the third standard result is, if two vectors, so the vector A and then another vector B, so which are having, so the same magnitude and the angle between them is 120 degrees. So if the angle between them is 120 degrees, so then the resultant is going to be, F. Then the resultant is going to be F. So understood? Two vectors having same magnitude and the angle between them is 120 degrees. So then the resultant is going to be same, equal to this. Okay, so this also you do it as a homework. So how do you do it? So just take A is equals to F, B is also equals to F, and then the theta is equals to 120 degrees. So you just calculate this one. Okay, so these are the three standard results everyone should remember. Okay, so let's keep this lecture short. So hope you guys understood the basics till now whatever we discussed. So just I discussed about the parallelogram law, addition and types of vectors, basics of vectors, and some questions. That's it. So in tomorrow's session we'll discuss, so what's a triangle law, and then what is vector subtraction, how do we do the vector subtraction, and then so we'll do some questions based on these topics. Okay, chalo guys, we'll meet in the next lecture, so that is tomorrow. So till then, keep studying. All the very best. Bye. Take care.